Hello students, in today's class we are going to study examples on direction cosines and direction ratios of a line. But before going to the examples on direction cosines and direction ratios of a line, quickly we will revise whatever we have studied in the last class. In the last class, at the beginning, we have defined angle between two non-intersecting lines, and we have studied how to find the angle between two non-intersecting lines. Then we have defined the direction cosines of a line as if L is any line, then we can find out the angle made by the line L with the positive direction of x-axis, y-axis and z-axis. Then the cosine of those angles is called as the direction cosines of the line L. Means if the line L makes angles alpha, beta and gamma with the positive directions of x-axis, y-axis and z-axis, then we will say that cos alpha, cos beta, cos gamma are the direction cosines of the line L. Then after that we have gone further. An important relationship between the direction cosines of a line. We have shown that if L, M, N are the direction cosines of a line, then L square plus M square plus N square is equal to 1. This is a very important relationship. What does this relationship means us? That the sum of the squares of direction cosines of any line is always equal to 1. So this relation is very useful in solving examples also. After that we have defined the direction ratios of a line. Let A, B, C are the suppose three real numbers which are proportional to the direction cosines of the line L, M, N. Then we have defined that L by A is equal to M by B is equal to N by C, which is equal to plus minus square root of L square plus M square plus N square upon square root of A square plus B square plus C square, which is equal to the plus or minus, as the L square plus M square plus N square is equal to 1. Therefore we will get plus minus 1 upon square root of A square plus B square plus C square. So this is a very important relationship. By using this relationship we can find out the direction cosines of a line if the direction ratios are known to us. So if A, B, C are the direction ratios of a line, if A, B, C are the direction ratios of a line, then the direction cosines of the line are given by L equal to plus or minus A upon square root of A square plus B square plus C square, comma M equal to plus or minus B upon square root of A square plus B square plus C square, and N equal to plus or minus C upon square root of A square plus B square plus C square. So, and obviously either we have to choose plus throughout or minus throughout in this one direction cosines. Okay, we have to choose plus or minus throughout. It is quite possible that A is positive, B is negative, C is negative. Then we have to choose A positive, B negative, C negative, but this plus or minus sign which is present in the multiplication. So throughout we have to choose the either plus or minus. It is important here. We have defined that the three numbers which are proportional to the direction cosines of a line are called the direction ratios of a line, and direction ratios of a line are also known as the direction numbers of the line. So we will mention that also, that the direction ratios of a line are also known as the direction numbers of the line. Direction ratios of a line. In short, direction ratios are written as DRS. So DRS of a line are also known as the direction numbers, also known as the direction numbers of the line. Direction ratios and direction numbers means the same. Okay, so and sometimes if the direction ratios are given, then how to decide whether those are the actual direction cosines or direction ratios? For that purpose we have to use this important relationship which are already obtained in the last class, and that relationship is If L square plus M square plus N square is equal to 1, then L, M, N are the direction cosines. Okay, so this is the important relationship. Now we'll solve some examples depending on the direction ratios and direction cosines in today's class. Let us begin with a simple but important example, and that example is that direction ratios are given and we have to find out the direction cosines of the line. Okay, so example number 1. So the first example is 6, 2, 3 are direction ratios of a line. What are the direction cosines? Direction ratios of a line are given as 6, 2, 3, and we have asked to find the direction cosines of that line. So as we have revised just now, we have to use the same formula for finding the direction cosines as the direction ratios are given here. So we'll solve this example. Solution is, let L, M, N be the direction cosines, we'll write in short as DCS, of the given line. Direction cosines of the given line, of which what is given? Of which direction ratios are given, of which DRS direction ratios are, A equal to 6, B equal to 2, C is equal to 3. Order is very important. Okay, order is to be kept as it is. So 6 to 3 were the direction ratios given to us of the line. So we have denoted them by the A, B and C. Okay, and LMN with the supposed direction cosines of the line. So now I will use that formula. So then we have L by A. First of all, I am going to write down the formula so as to revise it. Okay, L by A is equal to M by B is equal to N by C, and which is equal to plus or minus. In the numerator we have the under root of L square plus M square plus N square, of which the value is 1, that is known to us. So therefore I am writing the 1 divided by, in the under root we have A square plus B square plus C square, A square plus B square plus C square. Okay, so this is the formula which you have seen in the last class. Now, so therefore we will put the values of A, B, C and so on to obtain the values of L, M, N. After writing this formula, then the next one remaining part is simple. Okay, so therefore we get, therefore L by A means put the values of A, B, C. So which implies L by A means 6 is equal to M by B means 2. It is equal to N by C means 3. 6, 2, 3 were the values of A, B, C, which is equal to plus or minus 1 upon under root of put the values of A square, B square, C square. A is 6, therefore its square is 36, plus B square means 2 square, which is 4, and plus C is 3, so 3 square is the 9. So which is equal to plus or minus 1 upon 36 plus 4 is 40, 40 plus 9 49, and under root of 49 is obviously 7. So here it is plus or minus 7, which implies L equal to, now this transfer this 6, 2 and 3 one by one to the right hand side. So we'll get L is equal to 6 upon 7. So L is equal to 6 by 7, and we are choosing the plus sign out of this plus minus throughout. Okay, so L is equal to 6. So we are equating this L by A equal to M by B equal to N by C 1 by 1 with the this plus minus 1 by 7. So we'll get L equal to 6 by 7. Then M is equal to 2 by 7 and N is equal to 3 by 7. So we have obtained the values of L, M, N. So hence our final answer is hence 6 by 7, 2 by 7 and 3 by 7 are the direction cosines, means DCS of the given line, So like such, if the direction ratios are given, then the direction cosines can be found by using such method. Okay, so this was the first example that we have solved. Now let us move to the second example. Now the second example is, if alpha, beta, gamma be the angles which a line makes with the positive directions of the axis, then prove that sin square alpha plus sin square beta plus sin square gamma is equal to 2. Here it is given that the alpha, beta, gamma are the angles made by the line with the positive directions of axis. Axis means x-axis, y-axis, z-axis. Then we have to show that sin square alpha plus sin square beta plus sin square gamma is equal to 2. We will solve this example. So solution is, given that alpha, beta, gamma are the angles made by line with the positive directions of axis. Okay, let L, M, N be the direction cosines, in short DCS of the line. Okay, then we have, so then by definition we have L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma, cos alpha, cos beta, cos gamma we have. Okay, so therefore we will take the square of this. Okay, so therefore we have cos square alpha, plus cos square beta plus cos square gamma, which is actually the L square plus M square plus N square, that is equal to 1, which I have proved earlier. So that is equal to 1. Okay, cos square alpha means L square, cos square beta means M square, cos square gamma means N square. So summation of these is equal to 1, that we know. But cos square of theta can be written as 1 minus sin square theta. So therefore cos square of alpha is nothing but 1 minus sin square alpha, as the result that we require is in terms of sin square. Therefore we are converting this cos square in terms of sin square. We have cos square alpha plus sin square alpha equal to 1. Therefore cos square alpha is equal to 1 minus sin square alpha. Then plus, similarly here also we will get 1 minus sin square beta, and the last term also is plus 1 minus sin square gamma. Okay, and it is equal to 1 as it is. Now see here what we will get, 1 plus 1 plus 1 is actually 3. So we will get 3, then minus, we will take the minus sign common, then in bracket we will get sine square alpha plus sine square beta plus sine square gamma. It is equal to 1. Now we will transfer this negative term to the right hand side and 1 to the left hand side, and then we will get here. Therefore this can be written as sine square alpha plus sine square beta plus sine square gamma. It will be equal to, so it will be equal to 3 minus 1. Okay, so it is equal to 3 minus 1 means that is equal to 2, and this is that result that we wish to obtain. So therefore we have shown that sine square alpha plus sine square beta plus sine square gamma is equal to 1 if alpha, beta, gamma are the angles made by line with the positive directions of axis. This was the second example. Now we will move to the next third example. Now the third example is the vertices of a triangle ABC are the points minus 1, 2, minus 3, 5, 0, minus 6 and 0, 4, minus 1 respectively, which means that A is the point minus 1, 2, minus 3, B is the point 5, 0, minus 6 and C is the point 0, 4, minus 1. Then determine the direction ratios of the bisector of angle BAC. We have to find out the direction ratios of the bisector of angle BAC. So we'll solve this example. For solving this example and also for the understanding purpose, we will draw a diagram of triangle ABC first. So let us draw the diagram. See here, we have drawn the diagram that given point A, B and C, this is the given triangle, and let AD be the bisector of angle BAC. Let segment AD be the bisector of angle BAC. Then we have asked the direction ratios of AD. We have to find out the direction ratios of AD. And to find the direction ratios of AD, we require the coordinates of A and D both. But the coordinates of A are given to us, so we have to simply find out the coordinates of D. And to find the coordinates of D, obviously we require the length of AB and AC. After finding the length of AB and AC, then by using the section formula we can find out the coordinates of D, as AD is a bisector of angle BAC. So let us begin to find out first of all the distance AB and AC. Distance AB and AC we have to find out. By the distance formula we have by the distance formula AB is equal to, so it is equal to the square root of, use the coordinates of A and B. So AB is equal to the square root of 5 minus of minus 1. So square root of 5 minus of minus plus, so 5 plus 1, it's a square, then plus, next one is, it is 0 minus 2, it's a square, and next one is minus 6 minus of minus plus 3, it's a square. Okay, so 5 plus 1, it's a square. Then next one, as told just now, is the 0 minus 2, it's a square, and the third term is minus 6 minus of minus plus 3 bracket square, and obviously this is equal to, so this is equal to the square root of 5 plus 1 is 6, 6 square is 36, then plus 0 minus 2 is minus 2, minus 2 square is plus 4, and plus minus 6 plus 3 is the minus 3, minus 3 square is 9. This is the AB, which is equal to, so this is equal to the 36 plus 4 is 40, 40 plus 9 is 49, and under root of 49 is plus minus 7, but as this is a distance and distance is never negative, so therefore we have to take only the positive sign. So therefore distance AB is found to be 7. Now next one, similarly we will find out the distance AC. Now distance AC. AC is equal to the square root of, again AC is equal to the square root of, use the coordinates of A and C. So we will get the x coordinate of C was 0, so here it will be the 0 minus of minus 1, it becomes plus 1, so 0 plus 1 bracket square, then plus difference of y coordinates is 4, difference of y coordinate is 4 minus 2, 4 minus 2 bracket square, and plus difference of z coordinate is minus 1, and minus of minus plus 3 bracket square. We will compute this one, so which is equal to the square root of, so 0 plus 1 is 1, 1 square is 1, then plus 4 minus 2 is 2, 2 square is 4, plus minus 1 plus 3 is 2, 2 square is 4, so it is equal to the under root of 8 plus 1 means 9, and square root of 9 is plus minus 3, but as told earlier, as this is the distance between 2 points and distance is never negative, therefore we have to choose plus sign only. Therefore distance AC is equal to 3. So we have obtained distance AB and distance AC. Now by geometry we know that as segment AD divides the angle BAC, therefore the point D divides the segment BC internally in the ratio, which ratio? It internally in the ratio 7:3. Okay, so we have to use the section formula to obtain the coordinates of point D. The bisector of angle BAC divides, that bisector was the line segment AD, so it divides segment BC in the ratio, divides segment BC in the ratio, in which ratio? In the ratio AB as to AC, in the ratio AB as to AC, that is 7:3. We have obtained the length of AB and AC, so in the ratio 7:3. So therefore we will use the section formula. Therefore by the section formula, we get, coordinates of D as equal to, coordinates of D will be equal to, use the section formula, so we will get 7 into 0, then plus 3 into 5. Section formula in detail we have studied in as a preliminary, okay, divided by 7 plus 3. It was mx2 plus nx1 upon m plus n. Similarly for the y coordinates also, 7 into 4, then plus it is 3 into 0 divided by, it is again 7 plus 3. and for the z coordinate also we have the m z2 plus n z1 upon m plus n, which is here 7 into minus 1, then plus 3 into minus 6 divided by once again 7 plus 3. Okay, and these coordinates are nothing but this is same as, simplify this one. So we get 7 into 0 is 0, 3 into 5 is 15. So this is 15 upon 10. 7 4 za 28. 28 by 10. As the 3 into 0 is going to become 0. Next one is 7 into minus 1 is minus 7, and 3 into minus 6 is minus 18. Minus 25. Minus 25 upon 10. Okay, and this is nothing but, after simplification, this is nothing but this is 3 by 2 after dividing by 5 each. The middle term gives us 14 by 5, and the z coordinate is minus 5 by 2. So the coordinates of D we have obtained. Okay, so these are the coordinates of D. Now we have the coordinates of both points A and D. So therefore we can easily find out the direction ratios of the bisecting line AD. So therefore DRS, direction ratios of segment AD, okay, DRS of segment AD are, here we will write down the A just for your easy to comparison. So A was, the coordinates of A were minus 1, 2, minus 3, minus 1, 2, minus 3. Okay, so now A was this and D we have computed. So find out the direction ratios of segment AD. So therefore the direction ratios of segment AD will be, so direction ratios will be the difference of x coordinate, y coordinate and z coordinate. Okay, so it is 3 by 2, then minus of minus 1, 3 by 2 minus of minus 1, this will be the first direction ratio. Direction ratio means it is a set of 3 real numbers. Next one is the 14 by 5 minus 2, and the third one real number is minus 5 by 2 minus of minus 3. Okay, that is, simplify this one, that is 3 by 2 minus of minus 1 means 3 by 2 plus 1, and 3 by 2 plus 1 is obviously 5 by 2, 5 by 2. Next one, 14 by 5 minus 2 is the 14 minus 10 means 4 by 5. And lastly, minus 5 by 2 minus of minus 3, minus of minus 3 is the plus 3. So minus 5 by 2 plus 3 is minus 5 plus 6 by 2. Okay, and minus 5 plus 6 is the 1 by 2. So these are the direction ratios, and these direction ratios will write in a simpler form by cancelling the denominators. So to cancel the denominator we have to multiply each one term by the LCM of the denominator, and LCM of 2 and 5 is obviously 10. So we have to multiply throughout by the 10. 50 by 2, then 4 into 10 is the 40, 40 by 5, and 1 into 10 is 10, 10 by 2. Okay, and this can be written in simplified form. So hence 50 by 2 means 25, then 40 by 5 means 8 and 10 by 2 means 5 are the 25, 8, 5 are the direction ratios of bisector of angle BAC. Okay, so likewise we have solved this example. So today we have solved 3 examples. We'll stop here and I will continue with some more articles in the next class. Thank you.